So for your homework, section 2, I've asked you to look at a full Atwood question. So I thought I would tell you what a full Atwood is. I talked about this with the 3 students who were in class today on Monday. So a full Atwood is when you have a pulley, okay, so a pulley attached to a string, and the string is attached to 2 separate masses. I'm going to call these M1, I always have trouble drawing this, and M2. And we're going to say, for the sake of argument, that the mass of M2 is larger than the mass of M1. Okay, so how do we set this up? The setup of a half Atwood problem is very similar. So remember that this is what's called a coupled motion problem. So that means that the acceleration of mass 2 has the same size, the same change in velocity every second as the acceleration of mass 1. So we're just going to call that A. Okay, that's the first thing to remember. 2, we've got a string involved, so the tension on the 2 ends of the string are the same. That means that the force of tension from, let's call this in the string, from the string on M2 has the same strength as the force of tension from the string on M1. Okay, so keep that in mind. So we need to know both those things. After that, the first thing we do is we establish our coordinate system. We're going to pick the direction that the blocks are going to move. So we are guessing that if M2 is heavier, it has more mass than M1, that the M2 is going to head towards the ground and M1 is going to be pulled up towards the pulley. So that means that our coordinate system is going to be curved. It's going to follow the pulley, right? But positive X is going to be down on the mass 2 side. Let's just make sure we have the 2 there. And positive X is going to be up on the mass 1 side. Okay, so we put in our coordinate system. Okay, so the next things you would do, you would make a free body diagram for each block. And then you would have a system of linear equations, so make sure that you label the things that are the same. So go back and check these 2 things, that you've labeled them the same in your equations. So you might want to call both of these tensions just something simple so you know they're the same thing. So maybe you make them both equal to F sub T, even though it doesn't have a dealer feeler. And then you want to use elimination or substitution to solve for the acceleration. Okay, and once you're done with that, you want to check it. So what are some limiting cases you could use? Also, don't forget you know the force of gravity from the Earth on each mass is equal to mg. You should be subbing that in somewhere too. Okay, so limiting cases. What happens to the acceleration if m1 equals 0? What happens to the acceleration if m2 equals 0? What happens if the mass of m1 equals the mass of m2? So you should have some idea of what would happen, and then you should be able to check to make sure that your equation works. All right, so you may be interested because this is one of the questions, this full Atwood on worksheet, I think it's worksheet 4 that I assigned for homework.